Hello, Assalamualaikum. Today, me, Muhammad Faiz Naufal, I will be talking about how to do a speed reducing gearbox. My alarm ID is 019544 and I am from the ME44. Let's check it out. So, now what we are going to do is to do the input shaft. Well, to start off, we will need to normal to the front plane, and then we are going to draw a circle. When drawing the circle, we are going to set the radius or the diameter by 8 millimeter in diameter. So now we are going to boss extrude it. When we boss extrude it, we are going to do 40 millimeter of length, so it will become a cylinder. Then we will pick the top plane as the normal 2, because we are going to draw a center line from top to the bottom of the cylinder. Now we are going to draw a shape from 2 points. From these 2 points we are going to draw a shape. Then this point we are going to have a radius of 1.5 millimeter, and then the top, from the top to the top of cylinder to the top of the shape is going to be 5 millimeter, and then the inner part from the 2 dots of the inner part, then we're going to have it as 4 millimeter, and so the radius is 1.5. And then we are going to cut extrude it. When we are going to cut extrude it, we need to pick the offset and then at a different direction, and this offset, it will be maintained at 2.5 millimeter, and the direction is reverse, and it is put at through all. Okay, so now we already have the cutout of our cut extrude. So now we can see the shape of the new cut extrude. So draw center line, then we new center square. So the center square is placed on top of the middle of the center line, and then we put a dimension on top of the newly square that we did, and then we determine it as 0.6 millimeter, and the diameter, the length of the top of the square to the center of the circle is determined to be 4.5 millimeter. Okay, so we then fully define sketch so that we don't miss out any dimension that we did. So there's another addition of 0.68 millimeter and 8 millimeter, so we forgot about that. So now we already fully define it by using the function. So now we are going to boss extrude the new shape we are going to do. So we take the opposite direction and determine it at 10 millimeter of length. So boss extrude the shape that we want. So we pick that shape, Yes, this whole shape. So now we boss extrude it. Okay, so that's done. And then we are going to do a circular pattern around the circle shape. So we then press the outer ring of the circle, and then we have a circular pattern. So pick 360 degree on H1, and then determine at 10 with 10 shape. So there's a function where how many shape do you want of the rectangle on the circle. So we put it as 10. So we do the other side of the input shaft. So what we are going to now is we're going to chamfer the other opposite side of the input shaft. So when we are going to chamfer this side, we are going to determine at 0.5 millimeter. So now we already have our input shaft. Now is the input shaft for drawing. So we'll start off by the front side of the input shaft, and then we're going to do the top part of the input shaft, and then the side view of the input shaft. Okay, so now we are going to fill up the dimension of each view. So we knew the center mark. So with the center mark, we need to drag it from the front part. So we drag up until the top view, and then from that we drag it up until the side view. So like this we drag it. So drag it, and then there's that. So we drag a bit on a little there, on the right, on the left side and the bottom side. Okay, so now we do the dimension on the top view first. So we do smart dimension. So we're going to pick this part here. So put 0.6 millimeter. So we're going to place it in the middle there, so it can be viewed correctly. Okay, 0.6. And then from this, we do the rectangle, the length of the rectangle, and then it's on 10 millimeter. And now we're going to do the radius of the shape that we extrude just now, the extrude cut. Then the radius is 1.5, and then the length of the shape that we did from 2 point is, this one is the width of the shape that we extrude cut. So this one is 3 millimeter, and then the length of the extruded cut shape is 4 millimeter. Okay, and then there's that. So now we move to the side view, and then we do the same. So the 7 millimeter of the chamfered part of the side view, and then 8 millimeter on the non-chamfered part of this side view. So it's 7 diameter and 8 millimeter diameter of the side view of the input shaft. So, and then we pick the tool from the toolbox, and then we have the option where we can use the dimension to indicate the chamfered part of the input shaft. So 0.5 times by 45 degree. So when we put 0.5, it's automatically 0.5 in diameter. So we don't need to add another 0.5 just to show the length. Then the whole part of the input shaft is 40 millimeter. And then so we just put another 0.5, so we can show that it is 0.5, so we don't need to put another 0.5. So this length of the extruded cut part and the top part of the input shaft will be determined as 0.29 millimeter. So this one is 0.51 of the height of the rectangle that we extruded, boss extrude, 0.51. So pick the most bottom part, because sometimes we can, make mistake. Sometimes there is another hidden line in there, so we need to zoom in into the furthest we zoom into. So it's 0.51. Okay, so now we put the radius of the front view of our input shaft. So R4 indicates it's 4 millimeter in radius, and then we put the height 0.51 of the rectangle extruded boss. Okay, so now we do the hidden edges of all the view. We show all the hidden edges just to indicate which part of the is hidden. So you can see here, we do the hidden view, show the hidden view. There go the cut extruded part of our shape just now. So we are also going to smart dimension this part here, and from the top part of the extruded cut to the bottom part of the extruded cut is determined to be 1.21 millimeter. Okay, just pull it up here a bit so we can see it clearly. So we put another one. So it's from the top part of the outer input shaft and to the bottom of the extruded cut is determined to be 1.5 millimeter. So now we are going to do another part, which is the speed shaft. So in this speed shaft, we're going to draw a circle. Draw a circle here, and then we are going to smart dimension it. Put it 10.23. Then we're going to draw a center line, and then we draw a center square. So draw a center square here. Just put in any shape, then we're going to smart dimension it, so no worry about that. So on top here, we're going to determine the top part of the square rectangle is square. Center square is 4 millimeter, and then the top part of the square to the center point of the circle is determined to be 7 millimeter. And then now we are going to boss extrude it. So pick the part that we are going to boss extrude, which are the whole thing, and then the direction, blind, and so it's 40 millimeter in length. Then boss extrude this. Okay. Okay. So now what we're going to do is to cut extrude the middle part, but then we need to pick the plane, and then we're going to sketch again. So sketch the same face, the same dimension, so same radius. Determine the R is 10.23, and then the outer R, the outer radius, outer R, so outer radius. So we just put it at least bigger than that, and then we extrude cut it. So from this extruded cut, we are going to do a little bit minor difference of the extruded cut. So we're going to use the offset function, and 10 millimeter, and at the opposite direction of the offset. Okay, 10 millimeter. So now we can cut the middle part without meddling with the outer part. So now we go recut the middle part. So now we have our speed shaft. Now we go to the speed shaft drawing section. So now we're going to insert the front part of the speed shaft. Okay, and then the side part of the speed shaft. Okay, and that's done. So now we are going to insert the dimension of each view of the speed shaft. Okay, I believe there's no hidden line here, but we're just going to show if we do have. Okay, so just to play safe. So now pick smart dimension, then pick the top part of the top view. So do this 4 millimeter, and then the middle part of the outer view of the top view of the speed shaft is going to be 10 millimeter in diameter, in length, and then the radius is 5.12 of the front part of the circle, and then here is 2.29, and this one is 0.41. Okay, then where should we go then? Okay, we go into 30 millimeter of the whole length of the speed shaft, because there's a different level of the lock shaft here, so we're going to do a bit more dimension there, so just to indicate the difference in the level of the middle part and the shaft lock part. Okay, just to put another 3.12 on the top view, 3.12 millimeter. Just 10 millimeter. Okay, I don't think we have any more. I think, yeah, we already have covered it up on the top view. Okay. Okay, never mind. We move on to the output shaft. So the part 3 is the output. Okay, draw a circle. Let me check what diameter is the circle should be on the output. I think it's 10mm because all shaft is 10mm in diameter, right? So let's just put 10mm here. Okay, 10mm. Okay, 10mm. Then I think we forgot something here. Yeah, I think we forgot something. We should draw something here before we extrude boss this. I'm sorry, my mistake. We're going to draw a center line from the center of the circle. Okay. So drag it to the top. Okay, drag it up. And same thing, we're going to draw a center rectangle, center square, whichever we name it, center rectangle. And then the dimension on top of this center rectangle is going to be 4mm. And the dimension of the top of this rectangle to the middle part of this circle is going to be determined at 7mm. Okay, so we need the fully defined sketch so that we can fully define this sketch. The fully defined sketch is sometimes can be handy if we forgot something, so still can be used, but we cannot use regularly. So maybe if we forgot anything, then we use this part. So we pick our part, which means the whole part of the shaft of the shape that we did on the sketch, to make up the whole part of the shaft. Okay, 10mm. Alright, and that's done. Then we're going to draw again a circle. Sketch, pick the plane, then draw a circle. Okay, the radius is 5, the same dimension. So now we are going to boss extrude this again. So boss extrude only the circle part. Yeah, only the circle part. So 30mm. Okay. So now we top plane, normal 2. So now we are going to do is we do a cut extrude on the bottom part. We're going to have a new shape. Okay, pick the slot shape. So now we're going to smart dimension this slot shape. Okay, from both sides. Okay, and the dimension should be what should it be? Let me think a bit. I think it's the same as the input shaft diameter. Is it? Let me check first. Okay, 3mm. Yeah, same. So because R is 1.5, so definitely it's 3mm. So the length of this slot is 5mm. R can be determined at 1.5mm. The bottom part of the outer shaft to the slot is 5mm. Okay, now we already fully define it. So now we are going to cut extrude this slot. So the same thing, we do the offset, and then at the opposite direction at 10 millimeter. Okay, we just want to cut the upper part there. We don't want to cut the whole thing up or else we screw out. Okay, not that. Yeah, this one is good. This one is okay. This one is good. So change it up a bit, 3.5 millimeter rather than 2.5 previously. Okay, and then that's that. So now we have done the output shaft. So this is our output shaft, almost the same as the input shaft, but we have the different lock mechanism. Okay, let's just put it on the isometric view. Okay, and then that's that. So I forgot, literally forgot. So we need to camfer this up, 0.5 and at an angle of 45 degree. So now that we have fully done the output shaft. Okay. Okay, so now we are going to the part 3 of the output shaft, which is the drawing part. So as usual, put the front part, then the top part view, and then the side view. Okay, drag the center line, drag it up to the top view, then drag it up to the side view. Okay, then drag it up a bit from the left side and the bottom side. Okay, now we good. Okay, so now smart dimension. Okay, so let's do the top part. Let me do the front part first. Front part. So 4 millimeter on top of the rectangle, right, extruded, boss extruded, and then the diameter of the outer circle of the front view, which is 10 millimeter, and the inner is 9 millimeter. Okay, 9 millimeter in diameter. Then we go to the top view. Okay, so 4 millimeter. Okay, and then we drag the whole thing, so 10 diameter. Okay, so we don't need the 4 millimeter on top view because we already did the 4 millimeter on the front view. Okay, so 10 millimeter on the rectangle length. And then as usual, the slot are 1.5 millimeter. The length of the slot is 5 millimeter, and the slot length from the bottom part of the top view of the output shaft is going to be, so let me zoom in. Never mind, we put the 0.5 times 45 degree. Okay, take the bottom of the slot and then take the bottom of the top view. Okay, so 4.5 millimeter. Okay, So we show the hidden edges, hidden part of the single view of every single view of the drawing. So there's a bit of hidden view here. So here on the hidden part of here, we're going to draw smart dimension 1.5 of the extruded cut of the slot, then 8mm of the length of the slot, and the inner length of the slot is 5mm. Okay, and that's done. Which part here? So that's 1.27mm of the top extruded cut of the slot to the bottom of the extruded cut. Okay, so there's a bit of difference from 1.5 and 1.27 there to get that shallow shape of the extruded cut. Okay, because there's a different level here, we're going to smart dimension this as well. So smart dimension this 0.42. Okay, 0.42 here, and then 9.58. Okay, we just put it here so that it can be easily readable. Okay, and then which part should we add? Oh yeah, the length of the output shaft 40mm, and the inner length of the output shaft, because we have a chamfer there, so 39.5, which indicates that the chamfer length is 0.5. Okay, so we don't need to show it, but we're just going to show it. Okay, I think that's the. Then we're going to move on to the next part of the drawing, which is the input gear. So now we are doing the input gear rather than the input shaft or stuff like that. So now we are going to move on to the gear part. Now we draw a circle first. Okay, so draw a circle which twist it at 20mm here. Okay, so the inner circle. So smart dimension the inner circle here. So 8mm. Okay, so 8mm. So the inner and the outer circle we have drawn it and smart dimension it, so it is fully defined. So now draw a center line up until the inner circles, because we are going to draw the sketch for the inner circle first. Okay, so draw a square center rectangle on the inner circle, because we are going to extrude this part here. We are going to touch the outer circle later on. So 0.6 on the top of the center square, and then from top of the center square to the center of this inner circle, dimension should be 4.5. Okay, and then we're going to smart dimension this 0.49. So now we already fully defined this sketch. Okay, so what we are doing right now is we are going to trim this inner circle here. Okay, trim all this stuff. Okay, trim on the top here, those two lines between the square. Let's just zoom in a bit. So we do the circular pattern here. Okay, circular pattern. Then we put it 10 shape. So the number of the square is 10. Okay. Okay, cut that. Okay, this part cut here. Cut the line there. Okay, so now we are going to boss extrude, but only the outer circle. Okay, boss extrude this. $10mm. Okay. Alright. So we already have the inner teeth of the gear. So now we're going to do the outer teeth of the inner gear. Okay. Let's check the dimension again. So sketch on the pick the outer part of the outer circle here, and then pick the right side. Let's draw a center line again, because we're going to draw another shape on the top of the outer inner gear. Okay, center line. So we draw a line here, because we're going to do the teeth part. So we're going to draw up the outer teeth. You see what I draw, then you will understand what I'm trying to do here. Just draw any teeth like this, the shape trapezium like this. So we don't care about the dimension first. Just draw it like this shape. So now take the both point of the line, and then we make it symmetry. So now we release symmetry, and then we take smart dimension and make it 1.5. Okay, so pick the both the circle here. Okay, so we do the other way around. We put 0.75, so it already symmetric with the center line. See, 0.75 as well. 0.75 on the other side, 0.75 on the left side. So now we determine the degree of the angle of the line as 20, and the other side as well as 20 degrees Celsius, 20 degrees. Okay. Okay, when we do the fully defined sketch, we found out that we did miss a bit of dimension here. So 1.17 and 2.07. Okay. Now we extrude cut this part here through all. Okay, so now we already have the cut through part. So what will we do with this shape? We're not going to draw it, right? So first we're going to do the circular pattern using this shape. Okay, so pick this shape, cut extrude part. Okay, and then Sorry, I forgot that we need to add another dimension here. Let's cut that as well. Okay, add another dimension from the bottom of the new shape we did to the center of the circle. Okay, determine it to be 8.5. Now we did. Okay, and then that's done. Okay, cut extrude. Okay, if it's fully defined, we use the fully defined sketch. Okay, this fully defined sketch is very handy at times like this, so you don't miss out on any underdefined situation. Okay, so let's cut extrude this. Okay, so now it's already fully defined. Okay, we are fine right now. So fully defined, because you can see down there it's fully defined. Okay, then what we're going to do this circular pattern. Okay, where's the circular pattern here? Okay, it's on the linear pattern. Okay, pick the cut extrude part to be the main focus of the circular pattern here. Then pick the edge, equal spacing, 360 degree, and 14 number of shape. So now we already have the outer teeth of the input gear. There you go. From this weird shape, we can already draw the whole thing. So we don't need to draw one by one teeth and then we cut it up. So we don't need to do that. Just from this circular pattern here. Okay. Draw another circle here because we're going to cut extrude at the side of the new gear we did here. Okay, draw a big circle and then one smaller circle at this kind of scale. And then we're going to smart dimension the bigger circle as 50mm and the inner circle at 12mm. Okay, 50mm and 12 diameter. Alright, so now we cut extrude. So when we cut extrude, we cut extrude offset first. Offset of 2.5 I think, or 3.5. Oh, okay, 4mm. Okay, 4mm here. Just pick the right direction. Offset. Okay. Alright. So now we already have it. Because I forgot to mention, we did another new plane here, which is plane 1. So this plane 1 here is where you pick the reference and then you pick both of the side, at the left side and the right side. So and then we take the middle part here, so we can create a middle. So now we chamfer on the inner part of the circle just now that we did on the inner and the outer circle we draw just now. So we chamfer it 0.5. Then right now we're going to mirror it. So we're going to mirror the whole left side to the right side via plane 1. So it's going to be mirrored. So what I found out from this mirror function is that we cannot mirror the whole thing. What we're going to mirror is the cut extrude first, okay? So mirror the cut extrude first. Then we're going to chamfer it. Because if we mirror both of the feature, then it's not going to work. It's never going to work. It need to be one by one. Okay, mirror the cut extrude first via plane 1. Okay, so we can see the feature there. Then that's that. So we already cut it out. Then we chamfer it again so that it's symmetrical to the both side of the input gear. Okay, so last but not least is we going to chamfer the outer teeth of the inner gear. Okay, chamfer it by 0.25mm and remember pick the whole thing. Well, I mean you don't need to pick one by one of the chamfer. We already have a function where we can pick the whole thing, 55 side, as I demonstrate here. Okay, let me see. Chamfer. Okay, chamfer 0.25. Okay, see? Okay, we already pick the whole side. You don't need to pick one by one. There's already a function for that. This is how easy it is to chamfer the whole thing when using the circular pattern. So there we go. We already did 55 side. We don't need to press one by one. Just to it will already waste your time already. Okay, so let's just pick chrome. So chromium plate. Okay, then that's that. Then we save it as input gear. Input gear or inner gear is fine. Both of them have the same meaning. So now we are going to move on to the drawing of the input gear. So we do the front and then we do the same as top and the side view of the input gear. Okay, already give us a center line, so we don't need to draw a center mark there. Just drag the center line there from the front part to the top view, and from front view to the side view. Yeah, same thing. I just want to mention that there's a lot of hidden edges because there's a lot of teeth, so that's why there's a lot of hidden edges here. But I'm going to show it later on, because if we show it right now, it's going to lag the computer. So we just do the dimension first. Then once we finish all the dimension, then we do the dimension for the hidden part. Okay, what we going to start first here? Should we start with teeth first? Teeth of the circular pattern that we did just now. It's not the right dimension. It's not the right dimension here. We're not, because when there's a lot of teeth, you need to zoom in, like literally zoom in, very zoom in, because there's going to be there's another line there. So you're never going to expect there's another line there, and then it will disrupt your measurement. See, I pick from the whole, zoom in and zoom in there. See, there's another line there. Okay, so now that's complete. It's 20mm. So when we're dealing with lots of edges like that, we need to really zoom in. Okay, 10 millimeter. We don't need to zoom in there because we're just going to out for the width of the gear with just 10 millimeter. So now we're going to smart dimension the circles of the front view. 15 millimeter, 12 millimeter, then the inner circle there, R4, which indicate it means 8 millimeter in diameter. Okay, because there's a lot of circles here, so I'm trying to figure out which circle should I smart dimension. So it's not this, like it's not this, and definitely not that. Okay, maybe I can use this. Yeah, R10, which indicates the most outermost circle is in fact 20 millimeter in diameter, which is the same dimension as the top view just now we did as 20 millimeter, right? So then that's that. R10. This one I'm not sure, should we do a smart dimension on this part that's now. Okay, 11 millimeter in diameter. I almost forgot that circle. Okay. Don't need to do the R10 because we already did that. No need. I don't think we should do that. Yeah. Because there's a little bit 1.13 and 1.14. It's a bit slanted line, so I'm not really sure if I should put it or not. It's a bit slanted. Just a little bit slanted, but may have a little bit of difference by 0.01. So this chamfer here are 0.25. So meaning it's 0.25 millimeter of the radius of the chamfer. Alright. Then we choose the inner part of the chamfer here, just to indicate it has the same chamfer length. Okay, it's not the right, so we should pick another place where we can do it properly. No, not here. Where should we do it? Maybe on the other side. Okay, maybe this side here is kind of good. Oh yeah, I think it's this kind of. This one is kind of good. Alright. Then just put 0.6 here. Okay. Drag it out a bit. Okay. 0.6. Okay, let's move on back to the top view. Then show the hidden edges. See, there's really a lot of hidden edges in, and I mean this is only the inner or input gear. We haven't ventured out to the output gear. Output gear is much bigger, and there's really lots of hidden line on the output gear. So we're just going to pick this chamfer part here. Okay, pick the chamfer part. Pick the right tools. View tool, dimension, pick chamfer. Okay. Pick two lines, one from the chamfer and another one from the parallel line. 0.5 times 45 degree. Alright. Okay. And pick this line. Pick this line here, 0.5. So both of it is 0.5 on the chamfered part and 0.5 on the non-chamfered part. Actually, we don't need to do the other side because it's already symmetrical, but we're just going to make sure that it is symmetrical. Okay, pick this line here and pick the other side of the line. Okay, this is the cut extruded part when we mirrored it, remember? So 8mm here. Okay, we're just going to add another 0.5 just to indicate that it is symmetrical. This gear is. See, we need to really zoom in so that we don't pick the wrong line. If we pick the wrong line, it will indicate a wrong diameter, a wrong dimension. Most common happenly on parts where it is very it has a very lots of drawing on a very small scale. Therefore, we need to zoom in very deep. Okay, and then we are done here. So now we go to the middle gear. The middle gear is the middle part of the gear. Later on, I will show you why we name it as the middle gear. So the middle gear is kind of simple. We don't have the inner teeth as we had with the input gear. The inner or the middle, we call this one is the middle gear. Okay, middle gear, this middle gear, 20mm of the outer circle and 10mm of the inner circle. So repeatedly we going to draw another sketch here. Draw a center line from the center of the small circle up to the top of the small circle. Okay, then pick the centered rectangle. Okay, and then smart dimension. Then it's 4mm here. This is going to be the locking mechanism for the middle gear. Okay, 4mm. Okay, then drag the top part of the square rectangle, the centered rectangle, and to the center of the circle, and the dimension should be 7mm. Okay, it's not fully defined yet, so we need to find it, make it fully defined. So we add the 2.69 dimension there. So now it is fully defined. So now we trim these entities here. Oh, I think we found a bit problem here. Item is unsolvable item conflicts. Okay, we redo that again. Just pause extrude it. Okay, so we don't need to trim that part here. Sorry. So that's it. Extrude boss, the outer circle there. Okay, so we have the lock part there, the lock extruded cut there. Okay, so from here we draw another center line. So as well as we're going to draw the same shape as we did with the input gear just now. just for the teeth part of the outer gear. Okay. So this one, the dimension should be 1.5. And symmetry this from 2 points, then we symmetry with the center line. So we can also use the other part where we do the half of the 1.5 is going to be 0.5, right? So we just pick 0.75 from the center line and to the end of this line there. So we can also do that, but we do another method here, so which is the symmetry. So 20 degree on the left side and 20 degree on the right side of the line. So it is underdefined right now. Then the dimension is 8.5 millimeter. So now it is fully defined. So we can extrude cut it again. And there you go, through all. Okay. So now we as the same trend, we're going to circular pattern it. Okay, circular pattern the cut extruded part there, revolve around the side there. Okay, triangle 60 degree. Okay, and 14 shape, 14 teeth. Okay. So now we're going to chamfer the teeth of the gear. Chamfer it by 0.25. So pick the whole side. There's a function for that. So you don't need to pick one by one. It's going to waste your time again. So remember that 0.25. So there's 56 edges here. So definitely you don't want to waste your time clicking one by one edges there. Okay, fillet one. Oh sorry, it's not chamfer, it's fillet there. I'm sorry. So chrome, then we do the material as the chromium plate. So save it in isometric view, and then we are done. Now we go to the part where the drawing part for the middle gear. Okay, so as usual, do the front view, top view, and the side view of the middle gear. So as usual, when we dealing with gear, we have lots of hidden gears, so we shouldn't show the hidden edges first. So we just do the dimension there where we can smart dimension it first, then we later on we smart dimension the hidden edges. What is the difference between the middle gear and the input gear is that we don't have the cut extrude on the circle, where we have two inner and outer circle there, where and then we cut extrude and then we mirror it, so we don't have it on the input gear here. So R5, which indicates that the diameter is 10 millimeter in diameter. R10 is 20 millimeter, and the height of the rectangle of the shape where we cut extrude is 2.42. Okay, let's reposition it again for the R10. Okay, 8.5 there. Let's put that 8.5. Okay, and that's that. Okay, 1.15. So pick tools, camphor, tools again. It's the same tool for fillet as well, so we just use the same thing. It's 0.25 there. Oh, it doesn't work. It doesn't work here because it is fillet, so it's not working. We just do the smart dimension, the smart dimension. Okay, fillet and camphor are different things. Fillet are rounded while camphor are more sharp in surface, so we can put it. So therefore, this fillet is in radius dimension, where the camphor is in normal dimension. There's no radius, or only the length of the camphor. Okay, so this fillet, so 5mm on the difference between the inner circle and outer circle diameter of the front view of the middle gear. So now we move on to the side view of the middle gear here. 10mm or the width of the gear. So there's a lot of part that we need to zoom in there. Really zoom in very deep. What I'm trying to do right now is to get the height of the gear, but actually you shouldn't do this way. This is a very long way. Actually, you need to pick on the top part of the gear, and at the bottom part here. I didn't figure out when I did this. It's kind of silly if you look at this perspective here. It's kind of silly. You need to pick one by one, and wasting your time there. Actually, and then it doesn't happen. See? So what we're going to do is we're going to pick at the top part and the bottom part there. Okay, pick smart dimension. Zoom in very deep. Okay, pick 10mm. Then go to the bottom there. Zoom in again. Zoom in. Okay, it's 19.78. Okay, now we did the same for the top view. Let's do the teeth part. Okay, 1.17. This one is 1.62. To 0.28. Because there's a very small gap here. 0.08. This one is usually the result of the fillet we did just now. So it happened to be another line there. 0.08, 0.11. Very small. It's very small here. So let me pre-position this. Okay. 0.28. So it's same as the top part and the bottom part there, 0.28. Okay. So now we're moving on to the output gear. So this is the last part of the gear. So what we're going to do, this output gear has a different the dimension, because it's output, so it has a bigger circle of the inner circle and the outer circle. So we first make a circle shape, inner and outer. So the outer circle should be 60 millimeter in diameter, and the inner circle should be 20 millimeter in diameter, I believe. Okay, 60 millimeter, and the inner part there. Oh, 10 millimeter. Okay, 10 millimeter here. So now we, as usual, we do the sketch on the inner circle there. Then we draw the center line. Then we draw a centered rectangle there. Put it on the center line there. Then we smart dimension this center rectangle. Okay. Then 4 millimeter, the length of the rectangle, 4 millimeter. Okay, from the top of the rectangle, and drag this smart dimension to the center of the circle, and this length should be around 7 millimeter. It is still underdefined, so we are going to make it fully defined here. Let's trim this part. Okay, trim that, trim that. Okay, so fully defined sketch there. Okay, so now it is fully defined. So we add another 3.72 and 6 point something. Okay, now it's fully defined. So now we can boss extrude. So we are only going to boss extrude the outer circle there. So left the inner circle untouched. So now we have a hollow space at the center. So what we're going to do right now is to draw another teeth for the outer circle. So as usual, we draw the center line, then draw the line for the teeth. Okay, let's just normal to it so we can easily sketch it. Okay, insert line, just do it line, just draw it as the shape. Okay, just draw it like that. Okay, so now we're going to smart dimension this. So pick 2 points on the first line, then we make it symmetry to the center line there. Okay, so now it is symmetric. So smart dimension. Which was shall I smart dimension first? Let me smart dimension on the bottom part of the sketch and then drag it to the center dot, and we make sure it's 28.5. Okay, 28.5. So let's just put it 20 degrees here. It's going to be a bit weird here. And then we're going to make the right dimension for the line in the middle there, which we symmetric there. Okay, dimension is 1.5. Okay, so now we had the same shape for our circular pattern there for our teeth. Okay, it is fully defined. This sketch is fully defined. So now we can safely extrude cut this part for our teeth. Okay, extrude all. Okay, cut extrude it. So now what we're going to do is the circular pattern, normal to, or we either put it in isometric first. Then circular pattern. Okay. On the side there, 360 and 45 shape, 45 teeth. Equal spacing. 360 and 45. Okay, and that's done. So now what we're going to do is same thing. We're going to fillet. Wait, is it fillet? I think extrude cut first. Yeah, extrude cut. We need to extrude cut the inner circle and the outer circle. Yeah, we need to extrude cut. Do the same thing. We do the plane where we split the plane and then we have a plane in the middle, and then we're going to mirror it and then chamfer it as well. So it's 50 millimeter on the outer circle. Then we do the extrude cut this. Wait. Wait, I think I forgot something here. Okay, so we do a thin feature. Two millimeter blind. Okay. Okay, it's a different direction. So now we already cut extrude thin feature. So now we already cut extrude on the inner circle. Then we chamfered this part here. Wait, yeah, that part here, 0.5 millimeter. Okay. Okay, so now we are going to do the mirror, and then we have the plane number 1. So we're going to mirror the same thing, the cut extrude thin feature there, and then we're going to chamfer it again. So we mirror, and then we pick the feature that we want to mirror at the other side. Okay, pick the cut extrude thin. Okay, check the other side. Okay, so now we chamfer that. Okay, pick chamfer. Okay, 0.5 millimeter, and then we are done. Okay, so now for last but not least, we need to fillet the teeth of the gear. Okay, put in isometric, fillet 0.25 millimeter, pick the whole thing. So now we already have a lots of side here. So you definitely don't want to pick one by one, or else you're going to waste your time pressing one by one of the side. So we have lots of edges here. I believe it's 157. 157. 180 edges, so you definitely don't want to click every 180 edges, and definitely you're going to miss a lot of it. So this feature is very good. So now it is the end product of the fillet of 0.25 millimeter. Okay, and then that's done. We put in isometric and we save it. So before that, we pick the material, and as usual we put in on chromium plate. Okay, and that's done. So now we move on to the next part, which is output gear drawing. So as usual, we draw the front view, top view, and the side view of our output gear. As usual, drag the center line to the top view, drag the center line to the side view, drag a little bit down there, and drag a little bit left there. Okay. What we're going to do next is smart dimension. Show the hidden line. Okay, we just show you the hidden line there first. So 4 millimeter, the rectangular side. Okay, R5, which indicates 10 millimeter in diameter, 29 millimeter diameter on the first circle. Second circle is 30 millimeter, and the outer circle is 50 millimeter in diameter, or R25. So as usual, I'm trying to figure out how can I pull this diameter first, because I want to try it on the same side. Okay, 50 millimeter in diameter. So this the most outermost circle is 30 or 60 millimeter in diameter. Okay. Okay, the inner circle to the outer circle is 9.5, and then this between these two lines is 0.5 millimeter. Okay, then we do the outer circle. The inner circle is 10 millimeter. We're just going to indicate one by one of the circle length, so that we can actually understand what length is this circle with lots of circle in this front view. Okay, we're going to cancel that out because that's too far. Okay, we're going to pick this circle there. Okay, pick that. Okay, 5 millimeter. Okay. Okay, so it's 28.5 from the center of the circle. So we move on to the side view then. Side view of the output gear. So the width is 10mm. Okay, so pick at the top most of the side view. Then we zoom in. We really need to zoom in there. So there's another line there. So we really need to be careful when it comes to picking the right line for diameter. Okay, let's zoom in there again. Okay, zoom in again. Okay. So we pick these two lines, then we see 6mm of the cut extruded part there. Then pick this line 1.5. We drag it to the left side there so we can organize it much better. Okay, 1.5 here. Okay, 1.5. And this camphor is 0.25, 0.5 because it's camphor. Okay, so the camphor 0.5 times 45 degrees. Okay, 2mm. Just because the extruded cut just now we do it 2mm offset, right? So okay, I think we need to add another one here on the side view. Okay. Okay, pick that line there. Okay, 10mm. Okay. Let me see if we can put another dimension here, because we did the lock mechanism for the outer output gear, right? So it's 12mm in length as indicated. So it's same 12mm. Okay. Moving on to the next part is the housing for all of our gears. So this part is a bit long because it's kind of complicated. So first we normal to the front plane. Okay, normal to front plane. Then do a centered rectangle. Okay, and then put dimension 119 on the side and 70mm on the top, the centered rectangle. Okay, so now we pause extrude this, and we pause extrude around 35mm. So this is going to be the height of the housing, 35mm. Okay, So now we normal to on the side of the house. Okay, then we sketch on this plane. So we draw a circle. Okay, we draw on the near the bottom side of the circle. Okay, then we smart dimension this circle. Okay, the length of the circle from the bottom part of the house is 40 millimeter. And the diameter of the circle is 16 or 8 R8, 16 diameter. So we boss extrude. When we boss extrude this circle, boss cut this, we cut it at 8 millimeter. Okay, so now we go back to the normal to front plane. Okay, so now we edit sketch here. So what we're going to do now is we draw 3 corner rectangles here, okay? And then we're going to make a few relation between these 3 rectangle. This 3 rectangle, corner rectangle. Here we're going to make it have the same relation. What I mean by relation is that if we change one dimension of the rectangle, this relation is going to relate with all 3 squares, 3 rectangle here. So we make relation between these 2 lines here at the bottom. Okay, we make relation at the top 2 lines as well, at the left, the first rectangle and the third rectangle. Then we make relation on 6 sides of the rectangle. Okay, we make relation there, and then we put it as equal. So when it comes to equal, if we change the dimension of the side, all the side will be the same. So we put it as equal as well on the top side. Okay, I think we make a bit of mistake here. Let's do it again. Okay, so now if I show you, when we pull this rectangle, the number 1 rectangle and the third rectangle is going to move, while the second doesn't move. Right? See, this is what relation is. Okay, so we make it equal. So when we change the dimension, see, we change the dimension, all 3 together will change the dimension equally. So smart dimension is okay, 8 millimeter. Okay, so we put this dimension as 14 millimeter. So see, all 3 of the rectangle has same length. Now for this side, between these 2 number, first rectangle and second rectangle, we put as 6, and the second and third we put as 6 as well. Okay, it's a good function for relation when it comes to having rectangle, but we want to have a same dimension. Okay, so right now, why we have the second rectangle doesn't move together with this first and third? Because of the shape that we are going to do right now, the housing. Okay, so we draw a center line anywhere. And then we're going to smart dimension between these 2 center line, or between this bottom line of the first rectangle, and make it 50 millimeter. And then from the center line that we did just now to the center line of the second center line. So now we had a problem here. Maybe because I did something, a break problem with the center line just now. The second rectangle, the second center line. So we remove the center line first. Let's do it again. Let me figure out how should I do it. Parameters. It's okay, we delete it. Do a center line again. Okay, let's do it again, and then we smart dimension it again. Smart dimension between the 2 center line. Okay, so now it's not fixed. Okay, so now 39 millimeter. Okay, so from this center line that I did now, we can move the first rectangle. So we put it at 9mm. So you see, when you change the overall diameter of the three rectangle, it's going to change altogether, right? So this is what functional relation is. Okay, smart dimension. So from the second rectangle, top of the second rectangle to the center line is 50mm. Okay. So now that's done, we're gonna do another line to make the house for the shaft that we did previously. The shaft, all the middle shaft, all the input shaft, everything. So we do a line, and then we smart dimension it 15mm, and then we divide it by 2, so 7.5, to make it symmetric to the center line. Okay, so we do another one at the bottom there, 15mm as well, and then 7.5 to make it symmetric. Okay, 15mm smart dimension. Okay, 15mm. Okay, this is 7.5 divided by 2. Okay, 15 divided by 2 is 7.5. So now it's symmetric. So now we trim it. We trim this so that we can clear the way to make the house. So we can extrude the whole, all three rectangle, including the house. Okay, so now we extrude it, cut this part here. Let's remove this. So there's a big problem here because there's this line that doesn't connect it together. Okay, 89mm here. So now it's fully defined. So we can proceed with cut extrude. Smart dimension this first. That's that we don't miss out anything. So we don't need to do that dimension. Just for sure we don't miss out on anything, or else we're gonna create a problem later on. So we can get the whole this sketch that we did, and then we cut it at 32mm. We don't cut the whole thing, or else we're gonna make a hole for the housing. So we don't want to make a hole. Okay, so now we did sketch. So we have a clear cut of the inner part of the housing. So this is where the place where the gear and the shaft are going to reside. Okay. So moving on to the next part, we're going to add another feature here. So let's sketch this plane and add a circle. Okay, let's add a circle here. Smart dimension 15mm in diameter, and the length of the circle from the top of the housing, smart dimension that as well. Okay, to the bottom. Okay, $79mm. So when we check here, it is actually symmetric to the inner housing shaft that we did that. So you can see there. So now we extrude cut Now we don't want to extrude cut the whole thing. We extrude cut only 8mm there. So if you cut whole, then we gonna screw up the housing of the gearbox. So normal too. What we're going to do right now is we're going to cut this part where we don't want it actually. So we cut it by rectangle, corner rectangle. So we smart dimension each of the side between this rectangle and the housing of the gear is 5mm. So 5mm there, 5mm down here, and then 5mm on that side there. Okay, 5mm. Then 5mm here, 5mm on the side there. It's the same for all the square that we did. Then we're going to cut extrude. We're going to cut through all for these 3 squares, because we don't need this part here. It's going to be redundant, because if we create it in real life, it's going to cost a lot more. So we're just going to cut the unnecessary part. Okay, cut here. So now it's fully defined, so we can proceed with cut extrude. So cut through all. Just cut through all. Okay, now that's done. So the next part is we're going to do the side of the housing. We're going to have a bit of a dimension for the side here. So we're going to have a bit of a relation between these entities, these 3 entities, the line and the curve. So we offset these entities by 3mm. So okay, 3mm here, and then we're going to add a few lines at the outer house of this plane. Okay, add a few lines here, there, a dot there, and here. So after that, we're going to cut extrude this part here. Okay, cut it as 5mm. Okay, and that's done. See, this is what the function of the offset entities when you have lots of entities and you just want to offset it. So you don't want to cut that part there. So we're going to do the same thing, but at the other side. But right now we don't need to have the offset entities because it's just a square. Then we can just cut straight the whole thing. So I've cut from that corner until to this corner, and put it as 2mm only. Okay, pick that plane and corner rectangle, pick that corner. Okay, take that corner as well, then cut extrude 2mm as well. So it's going to be the whole thing 2mm except for the offset entities plane. For the offset entities plane, we're going to cut it at 5mm. Okay, so on the other side it's going to be 2mm only. So corner square, from the corner there to the corner here, then just cut extrude again 2mm. Okay, so you see the shape that I'm trying to do right now. I'm just going to cut 2mm through these sides. So 2mm here as well, corner rectangle again, to the corner there, then cut extrude it. Okay, cut extrude here. Let's pick the plane, then corner rectangle again. Okay, cut extrude it 2mm. So now we go to the plane where it has these trim entities. So we're going to do the same step. So sketch first. Let's just pick these three entities first. Straight line, this curve, and the straight line again, and offset entities by 3mm. Okay, and then we make a few lines. And then from this few line, we cut extrude it by 5mm. Okay, so cut extrude 5mm. Okay, done. Just want to check it again, make sure there's no problem with it. Okay, cut. Okay, now on the other side here. Okay, pick this plane, take the corner rectangle. Okay, take the corner there, and then cut extrude 2mm. Okay, 2mm here. Okay, see, 2mm. So pick that plane there. Okay, pick the corner, do a corner rectangle, and then cut extrude 2mm. So make sure you pick the right corner, or else it's going to screw up the shape for our housing here. Okay, pick the right corner. Just gonna make sure that we pick the right corner here. Sketch this plane, then take the corner rectangle. Okay, okay, drag it to the right corner. Okay, okay, then we cut extrude it by 2mm again. Okay, cut extrude 2mm. This part here. Then we remain one last part here. Okay. Okay, sketch this plane, pick this plane. Then pick corner rectangle, choose the right corner. and then cut extrude by 2mm. Okay, that's done. Okay, look from every side here. So now what we are going to do right now is we're going to place the fillet for the inner part of the housing. So she is trying to look which part, but right now because it's going to fillet the whole housing, so we're not going to pick this function, so we're just going to pick one by one. So 5mm fillet, just pick one by one. Okay, pick here. Then pick there. Move to the other side. Pick this fillet here. Pick that fillet here. Okay, move to the down. Move to below. Okay, 0.5 there. 0.5 there. 0.5 there. And 0.5 here. 0.5 fillet here. 0.5 fillet here. Okay. So we are okay with this fillet. Now we can go with it. Okay. You know, we actually not done yet with fillet. We have a few more, because this is a sharp edges here, so we need to fillet this part as well. So fillet this corner here, fillet this. Okay, fillet this. So as you can see, this function is actually viable for the outer part, so we don't actually need to pick one by one. Unlike the inner part, it actually want to fillet the whole thing, so we cannot do that because or else it's going to screw up our housing. So we fillet this up. Okay, and that's done. So now we're going to fillet the upper part of the housing because it's still kind of sharp. Fillet here, fillet here, fillet there, but we cannot pick the whole thing, or else you're gonna fillet those line that have a curve there. So we're not going to use the function where it can fillet the whole thing. So no. So we're gonna pick one by one here. Okay, and the last part here. Alright. Okay, so that's done. Okay, you can fillet it. Okay, now we are done with fillet. Okay, just to look again if we miss anything before we move on to the next part. Normal too. So we're going to create a new housing for the shafts at the middle part there, because we missed that. So now we pick this plane here because it is at the same line with the part here, and then we draw a line, any line, maybe center line or any line there. Just pick center line and drag it to the bottom of the housing here, 35mm. Okay, so draw a circle at the center there and smart dimension it. Smart dimension circle, make it 15mm. Okay, so now we can extrude boss. We're going to extrude boss, but not the circle. We're going to boss extrude. Oh wait, we need to draw a rectangle first. Yeah, I forgot. Okay, now we can boss extrude. We boss extrude, pick this part here and in reverse direction. So you can see here. So yeah, so you see. Now this is the part where we house the inner shaft here. And we're going to do the same at the bottom part here. So draw a line again, draw a circle and draw a rectangular corner. Okay, 35mm, drag it to the bottom of the housing. So draw a corner rectangle here, and you need to draw a circle as well. So pick circle and smart dimension it, make it 50mm. Okay, so now we can boss extrude it. So boss extrude, and then opposite direction, sorry. Okay, that, make it 6mm, boss extrude. Alright, and now that's done. Now we are moving on to the housing for drawing part. So as usual, we're going to put the model view, insert the front view, insert the top view, and insert the side view of the housing drawing. Okay, let's put it here. Let's put the top view there. Let's put the side view here. So insert smart dimension. So 60mm on top of the top view, 70mm on the overall of the smart dimension for the dimension of the top view. And then which dimension should I use? Okay, this one is 20mm, the byproduct of the fillet that we did just now. So it's 5mm to indicate that the fillet that we did is in fact 5mm radius. So now we're moving on to the front view of the housing. So this fillet we indicate is R5, which is 5 in radius. So we're just going to indicate that the outer part and the inner part of the fillet that we did just now is in fact 5mm in radius. So same fillet. Okay. So this one is 6mm of the side, where the part where it goes to fillet transformation, and then from this we take the overall width, the width of the first rectangular part for where we insert our gear, 27mm and the 14mm on the first rectangle. So this one is 50mm in diameter, where we house the shaft, and this one is 8mm in diameter for the casing. Just going to do a few dimensions just to indicate that it is follow the housing dimension that we trying to do. So 24mm. Okay, then we do this part here, 24mm. So now we move on to the side view with the overall length. Okay, let's be the overall length for the part where we did the chamfer, 119, and this one is 115. So that's a difference of 4mm from the fillet we did just now. Okay, this part here is 85mm. Okay, this radius of the curve that we did for offset just now is R 10.5 radius, and this one is 29.94, almost 30mm. This one is 68.94mm. So we're going to show the hidden edges here. So let's show the hidden edges. So as you can see, that's the depth of our housing where we put our gears. So there's a gap between 3mm. Therefore that's why we cut extrude around 32mm just now. So there's a little bit clearance of 3mm there. So this one is 24mm. So it's 6mm in diameter where we put our housing for our shaft. So it's 40mm where we cut extrude for our gears, for our gear housing, sorry. So let me just check. So that's the end of it. So we're going to move on to the next part, which is the housing where we mirrored the housing in. So we go to the assembly function, assembly SolidWorks, and then select the part where we going to mirror it. So which is the housing that we did just now. Move it into here. Okay. So what we're going to try to do is we're going to mirror this whole thing, this whole housing here. And what we're trying first we need to do is make a reference plane, sorry. So it is fully defined. So face 1, make it 0mm face for the face 1, and then mirror plane on the plane 1. So as you can see here, it is not fully mirrored because it has the opposite direction. See, if I did this mirror, it's going to screw up this whole housing thing. So go down here, has create opposite hand version of the mirror. So you can see here it creates the opposite hand version of the mirror that we really want to see. Now we click on, then we have the perfect housing, where both of the housing where we can put all our shaft, gears, stuff into it. So what I'm trying to do right now is that I'm going to save this mirror part here into a new file. I'm going to select it and make it a new part just from this mirror. So I don't need to do a whole housing just for this part. So pick, save it. Let's hide the first housing here. Because we're going to only save the mirror part, so we're just gonna hide the first housing here. Okay, save it. Okay, open the specified file in a new window. Okay, so this is the mirrored housing. So we already saved a whole housing from the mirror. So now we go back to the assembly. We cut back this mirror, and then we insert component. We insert the mirrored part again. So there we go. Voila. Okay, let's put it aside here, or maybe we can just put it somewhere else. We can put it later on, because right now we're going to assemble the whole thing first. Then we're going to put the upper housing. So now normal 2. So first we're going to insert our input shaft. Okay, here let me insert component, input shaft, browse it. Okay, there we go. Now we rotate this a bit just for easiness for it. Just rotate it. So now we're going to make it with the shaft to the housing of the shaft. Okay, there you go. So this is the input shaft housing. So it can still move. As you can see here, it still can move. Okay. So now insert a ball bearing from the ball bearing tool. Take the angular contact. Okay. For each housing we have a different ball bearing specification. So from this specification, I believe it's 788. Then the serial number of the bearing is 788. Okay. Let's be the size. Oh, sorry, 388. Sorry. Okay, 388. So let's discard that. Okay, so now we're going to mate this bearing with the housing of the shaft housing. So let's mate it. Make it coincidence. Okay, that's done. The shaft still can be moved. Okay. Now with a component, we insert the input gear because it was meant for the input shaft. So let's put input gear. Let's rotate it for easiness. Okay, rotate it up. Alright. So now we're going to meet it with the teeth of the input gear. So let's meet it. Pick the inner part here, and then pick the cylindrical wall. Okay, then we do it again. It's not that. Pick this part here. So still can be moved. So there's a big problem here. Let's do the meat again. Okay, move this first. Okay, make this and the cylindrical wall of the input shaft. Okay, concentric. Okay, make it first, then we can do the coincidence. This made between this teeth and that teeth. Okay, alright, that's that. So now we can still move. We can move together, the shaft and the gear move together, but right now the shaft is movable. So what we're going to do is we're going to mate again between the gear and the housing, but we're going to place a little bit of length between these two walls. So it's going to be 2mm here. Okay, so now you can see it doesn't move at all, so you can rotate at place. So now we're going to insert another component for the middle top part of the shaft. So the shaft that I included here is going to be the speed shaft. So we're going to rotate it again. Rotate. Okay, for easiness purpose. Okay, and then we're going to mate it. Mate the shaft and the housing. Make it concentric. Okay, so now it can be moved here. Now we're going to add another bearing. Angular contact. So this bearing has a different spec because the dimension between the input shaft housing and the middle gear housing is different in length. So that's a different size. We pick 1712 here, 1710. Okay, so we discard this bearing. Okay, so now we're going to make these two bearing and the wall of the housing. Okay, made it up. Okay, now we insert the output gear, the big gear. Okay, so we're going to rotate it again. Now we're going to make concentric with the shaft. Okay, so it can be moved into the shaft. So now we're going to make coincidentally with the teeth and the locking mechanism of the speed shaft. Okay, and that's done. So it can be moved. But right now we're going to do some relation between the input gear and the output gear so that it can be moved collinearly. So let's see what we're going to do here. Let's make the teeth doesn't touch each other. So we're going to zoom in a bit. Okay, let me check here. Okay, it is coincidentally 0. Let's make this here. Okay. Okay, let's move it a bit. Okay, like it doesn't touch its feet, any of its face. Okay, everything's fine. So now we're going to do a mate here. Okay, so now we're going to do a relation mate and pick the mechanical mate and pick the gear option. So the ratio between the input gear and the output gear should be 14 to 45. It depends. It has a few calculation between any gear that you want to put. There's a few calculation. Okay, let's mate it up. Okay, let's move it little by little so it doesn't touch or it doesn't overlap with each other, so I can prove this gear is working perfectly fine. Alright, checking a little bit detail here and there. Okay, it's moving. As expected, it's moving. So now we're going to not hide the wall here because we're going to move on to the middle part, which is the center rectangle of the housing. Let's insert another middle gear. Okay, the middle gear here. So let's rotate it. Let's rotate the middle gear and make it concentric mate to the middle gear or main speed shaft gear. Made it up. Okay, so it can move concentrically. Okay, so now we're going to make it coincidentally. Okay, that's done. Let's see if we can move properly. So we don't need to add another mate because we already did the coincidentally mate. with the speed shaft. So now we move on, add another speed shaft for the bottom housing of the shaft, and add another output gear. Okay, insert component, add additional speed shaft, okay, rotate the shaft. Okay, as usual, we're going to make it concentrically with the housing shaft of the speed shaft. Okay, we made it. Then we add another angular contact bearing, 1710 bearing. Okay, and that's done. Okay, discard the bearing. Okay, make the bearing with the housing of the shaft. Okay. So now we're going to insert the output gear again. Okay, rotate the output gear again. So we're going to make concentrically to the speed shaft. Okay, made it up. Okay. So now it can be moved. But still we need to make it coincidentally with each other. Okay, let's move it here a bit. Okay. Okay, move it a bit. Then we coincidentally made it. Alright. So that's done. Okay, some problem can happen here. Pick the right side. Okay. Now that's done. Okay. So from here we need to make the ratio of the middle gear and the output gear again. Same ratio, which is 14:45. So make it mechanical mates. So coincidentally first, and then we do it mechanical mates. So we must not touch each other face first, or else it's going to be a big problem there. Okay, move it a bit. Alright. So now mate, mechanical mate. Choose the option mechanical mate. Pick one side of the face and to the other teeth of the face. Okay. Choose the option mechanical mates. Pick the gear option. Ratio 15mm to 45mm. (14mm to 45mm). Alright, that's done. So now it can be moved. Can move together with the first and the second gears. So it should work somehow. Alright, it's working. It doesn't overlap. And that's good. So now we move on to the third rectangle of the housing. So insert the gear. Insert the I think this is the wrong gear, I believe. Yeah, this is wrong gear. This is wrong gear. So let's do it again. Let's remove this gear. Insert component. Pick the right gear. Okay, so this the middle gear. See, the socket is the same. So let's rotate this component. Alright. Then we're going to make it concentrically. Made it. Alright. Okay, that's done. Now we move it a little bit. So now we're going to make it coincidentally. Okay, and that's done. Okay, so we insert component, the output gear. But first we need to insert the shaft first. So then we can output. So we insert the output shaft, the last shaft of this housing, of this gearbox. Okay, we rotate it for easiness purpose. And then we're going to make it concentrically with the housing again. Okay. Let's move it a bit. So now we're going to pick the bearing for the outer shaft. Output shaft, sorry. Pick the bearing. Let's just pick another component first. Pick the output. Pick the output gear, rotate the component, move it coincidentally, and made it coincidentally again. Okay, move it a bit. Let's make it. Alright. Okay, so there's a little bit gap there. So we're going to add an angular contact ball bearing. Okay, pick the 388 size. Okay. Pick 388. Alright. Okay, we discard that. So what we're going to now is we're going to make it coincidentally. The outer gear and the input gear. Okay, made it coincidentally, so there's no gap. What we're doing now is we hide the outer wall of the housing for our easiness purpose. Now we move this gear so that it doesn't touch each other, and we need to do that because we're going to do mechanical meets. So pick a face of the input gear, pick a face of the output gear, and then we mechanical meet it with a ratio 14mm to 45mm. Okay, so made it. Let's check if it's working. And yes, it's working perfectly fine. It doesn't overlap with each other. Alright, so let's check the overall gear. Does it move alright? Everything is alright. Does it not move in any weird way or something? Let's check it out. Okay, let's remove the height feature. Okay, it's working perfectly fine. All the gears moving, and as you can see here, the output shaft is moving at a slower pace while the input shaft is moving at a very high pace, which means that the output shaft is revolutioning at low RPM, while the input shaft is revolution in high RPM, which means in speed reducing gearbox, the input should be high so as the output should be low. When it does that, it is speed reducing. It means it's reduced the speed, the RPM, but at the same time it also increased the torque. So it reduces the speed to increase the torque. That's the function of the speed reducing gearbox. So now we're going to insert the housing, the upper housing part, which we did the mirror part here. So let's move it coincidentally. Alright, move it coincidentally here. Okay, let's move here a bit. So we're going to move coincidentally again, but at a different phase. Let's pick this part here. Okay, now we'll pick that part again, that face and this face. Alright, so now our housing are imperfect. So there we go. This is the assembly for the speed reducing gearbox. I've learned a lot from the speed reducing gearbox, lots of mechanical stuff, especially these mechanical gears, how it moves, how it works, the ratio, the T's between these input gears and output gears, how the mechanical mates move, the bearing, and everything single stuff working in the speed reducing gearbox. So this is the assembly part of the speed reducing gearbox. So now we're going to do the exploding for the gearbox, speed reducing gearbox. First pick the house first. So pick the explode step type. Okay, so it moves in opposite side between each other. Then we pick the other explode step, so it doesn't move together again. Okay, let's move it. Now we pick both of these housing and move it together again. Okay, select this, select that housing, move it on x-axis. Alright, and now we pick the explode step number 2 and then we move it together. You see, it's now we do the gears. So we take one whole of the gear and shove in the bearing, pick the whole stuff, move it out. Okay, let's move it on the Z axis first. Pick it again, move it on the Z axis. Okay, move it a bit, then go to the Y axis, select the items again, go Y axis, go down on the Y axis, down a little bit more I think. Okay, let's go down again. Okay, I think that should be enough. Okay, let's move the other part as well. Alright, move it on Y axis. Then pick the item again, select the items, move it on the Z axis. Okay. Move it on the y-axis again, move it down a bit, then we move on the x-axis again. Select all the items again. Okay. Alright. So take this part, select all the items. Okay. Okay, move it on the Z axis. Okay, every item is selected. Move it on the X axis. Okay, move it a bit. Alright. Okay. Move it on the Y Z axis. Select all items. Go to the make it align with each others. Okay. So now what we're going to do is we're going to explode every single one of these select the items, and we're going to explode it step by step. So step by step, select one item, select each item again, select the bearing. Okay, select that bearing as well. Okay, move it. Okay, select this bearing. Okay, select that bearing. Okay, move it together. And now we move the last part, all four last parts. Okay, select all this and move it a bit. Okay, that's the explode view. Now I'm going to show you the exploded view or animation.